Hello.
Hello? Buenos dias. Konnichiwa. Hey, hey, gumbo. Hola.
You know that
Ciao.
all these hellos are like in subtitles, right? Like they show you in subtitles.
That's why I did it. Okay. Okay. All right. So approximate area under the graph of a function. So now we're gonna approximate. So approximate means we're gonna estimate what we have, right? So whenever we're doing that, is an exact answer? Say no. Yeah, I said say no. Say no. Okay. All right. What we're trying to do here is, okay, approximate area graph under a function. So we're going to start by, the blue line is my f of x. So that is my function in which I'm trying to find a area of it underneath. And what am I using here in this case?
We're separating it by small rectangles.
Small rectangles. There we go. So we're approximating it using small rectangles. Now, when I'm looking at this, if the rectangle is over the function, that would be a overestimation, right?
Yeah.
If it is under, so you see the little boxes where it's not filled in, that would be a underestimation, right? So we're estimating overs and unders here. So right here. So graph of the constant function f of x equals h. So for what we have here, right here, this is my h value, okay? H. Height is h. From A to B, from some point from B to A, that's going to be my basic width, right? This is a rectangle, isn't it? This is a rectangle. So we're basically just trying to find the area of a rectangle, right? So width times height. But for calculus, my height is determined on whatever my function is. So it's not always going to be a straight line. You're going to have some curvy line off of it. So this one right here is going to be like a step function. So we're going to find the area of each piece that is going to be enclosed. So there's different ways that we could actually try and look at where the function would be. So I'm going to show you what a first one would be. So if I am taking this like this, this would be an underestimation. Okay, this is an underestimation. This is a left-handed estimation. A left hand means I'm connecting the left end of my rectangles, the left corner of my rectangles, to my function. Okay, that's a left hand. So that's left hand. Next one, I'm going to do a right hand. So if I say that, then the right hand would be looking something like this. The red one there. So that would be a right hand estimation, so that the right upper corner of each of the functions connects to that line. So in this case, the left hand would be what type of estimation?
Overestimation.
Left hand. Blue. Blue is a,
Overestimation.
look at the pieces that are white. So this one right here would be, blue would be a over, and the red would be under.
That's where you live.
Yes. Okay.
No,
It's not that. But I have one person that's actually agreeing, and other people that are sitting there like, what? You know, got both earbuds in and is trying to ignore me.
It seemed like he was wrong, so we were like, what?
Yeah, I felt bad. You can't do this to me.
He's
It's the same thing all the time. Okay, and this guy's over here just watching Doodle Jump on his phone. Okay, yeah, he's got like Minecraft how-to videos going right now. Okay, so there's one more type to go along with this. So the other type that goes along with this is called midpoint. So I would be connecting the midpoint of each of my rectangles. Now, the midpoint would be actually more accurate than left or right, because it gives you a little over and a little under. So these ones are going to be more accurate than most. All right, so we're going to do an over, we're going to do an under, and we're going to, where W is 1, and redo this. Okay? Now, for this one right here, lines, approximate area under the graph, enclosed by the graph, 12x plus 3, and the x-axis, and the lines 2 to 4. From 2 to 4, okay? So, let's start with which one would be an overestimation? In this case right here, is this going to be a left hand or right hand?
Left hand.
Think about over.
Yeah.
My rectangle has to have
If you put
empty
it
space.
left, so-
An overestimation,
Oh.
it would be a right hand.
Oh, over.
That's what I'm talking about, okay? So for the overestimate, I'm going to have right here. So overestimate, so I'm going to have empty white space right here. So the area is equal to, what is my width? What is my base? The B minus A is going to be 4 minus 2 is
2,
times. What is the height of my rectangle?
5,
5. Which gives me 10. And that's 10 units square, right? Because they're area. Now, let's try a underestimation. So I'm going to do an underestimation. So an underestimation, A would connect to the left-hand side, right? So the left, right here. There we go. So it's going to be that one right there. So what is the base of this?
2,
2. So I'm going to put 2 times. What is the height of this now?
4,
4 is 8 units square.
wait,
2 times 4.
units.
UNITS. I'm sorry, the pen. Yeah. All right, so now we're going to redo it, but we're going to make our W being 1. So now we're going to make our W be 1. So I'm going to redo it with the overestimation. So now that means I'm going to have a right hand. So that means that my width is going to be 1. So I need to go, so if there to there, and then from here to here. So I have 2 boxes here now, right? Or 2 rectangles.
That's how I know.
So with those 2 rectangles, so we're going to have 2 areas I'm going to add together. So my area is going to be equal to, what is going to be my width now? 1. So it's 1 times, so here's part 1 and here's part 2. Okay? So, for that information, what's the height going to be now?
4.5.
4.5, because it's halfway. So right here's 4, right here's 5. That should be 4.5, right? Okay, 4.5. Which gives me,
4.5.
crap, 4.5, right? Plus, what's the other side? What's my width? 1. And it's going to be times my height? 5, right? So this is now an overestimation, so I'm going to have 4.5 plus 5, which is going to give me 9.5. This is still an overestimate, right? Yes. My width is smaller. It's making it closer to an actual value, though. So it's what it's closer to. So let's take a look. And so now I'm going to redo the next one and overestimate. So I'm going to take this. Okay, so now it's going to look like this. So look like this. So again, same boxes, 1 and 2. Box 1, my area. My width is 1, my height is, what is it? 4. Plus, box 2, the width is, the height is, which is going to give me 8.5. And these are both units squared, right? So, if you notice, the overestimation has come down, right? And the underestimation has gone up, hasn't it? So, we know that if you add more rectangles, this gets closer, right? Okay, add more rectangles, this gets closer. Hey, you guys, you gotta leave space for the Holy Spirit there. Alright. Alright, so now we're going to do this one right here. So this is the area under the graph, x squared, from 0 to 10 by using lower sums of n rectangles that lie under the graph. So 2 subintervals. So I actually have my graph here. So I try to make it big as I possibly can because it makes it easier. So I have 1, 2, 3, 4, 5, 6, 7. That's 10 right there. Barely see it.
No, does it start one?
I think it's, wait, that is 1.
Yeah.
2. Okay, so here's 10. Okay, there's 10. And then here's 0. And if I want 2 subintervals, okay? So it's always going to do like this. It's always going to end up with B minus A, B minus A all over N. This is going to be an important equation for whenever we're doing these. So it's actually all my x values from start to finish divided by how many parts I want to break it up into. So in this case, what is my B value? 10. What is my A value?
0.
What is my N value? 2. So it goes from
0 to 5, from 5 to 10.
let's see. 1, 2. Yeah, that's right. Okay. So there it is. That is my 5. So under a graph, lower sums. Lower sums. So that means in this graph right here, is this going to be a left hand or right hand?
Left hand.
Left hand, right? Because I want them to be on the left hand side. I want them to be under. If I use right hand side, would it end up being over? Say yes. Yes, because my right hand would be right here, wouldn't it? And it would box it, and it would have a lot of stuff that's not under my graph, right? So, for my first interval, my width is 5, right?
Yeah.
Width is 5, but what's my height?
0.
0. So my area would equal to be 5 times 0 plus. So now, if it's left hand, that means this is my next rectangle here, right?
Mm-hmm.
Yep. So what is that going to be now? So how do I figure out the f value, the f of x? I know my x is 5, right? Okay, I know my x is 5. So how do I figure out the f of x? This is not cuddling 101. Okay? That's at college. You gotta leave some space for the Holy Spirit there. Okay? Get off him, girl! Thank you. Alright. So, someone say plug it in.
Plug it in.
Where are we plugging it into? I'm plugging 5 into where?
Graph of that.
F of x, right? So my f of x. So 5 is going into my f of x. So what is my output value going to be? 25. There we go. So it's going to be 25. So it's actually f of 5 gives you 25. Okay, so it's going to be my width is 5 and my height is 25. So what is the area under this, all this right here going to be now? Add them up.
125 plus 5, 130.
What's 5 times 0?
Oh, 0.
Okay, so my area is 125 units squared, right? ¿Está muy fácil?
Sí.
Yeah.
Put it away.
There's some messages.
No, I don't want to hear about your Instagram, your Twitter followers, your Snapchat, your Reddit users.
It's about my flight back to Ukraine.
Huh?
It's about my flight back to
You're not going to be deported for at least a couple weeks, okay? You're going to be okay.
At least a couple weeks. Thank you for prognosis.
Okay,
That's how I get through the day.
make sense?
I'm not even kidding.
Now you're focusing so much.
Okay, what am I doing for the next one? Class,
Yes.
how do I set up the next one?
Each two.
Divide
Okay, do it again, do it again.
10 by
Each two.
Where am I starting at?
From 0 till like 2 units.
Oh, no. What I say the formula is that important?
you're gonna do minus 10 minus 0 over 5.
Yep, 10 minus 0 over 5, right? And this is going to represent my width value, right? This is going to be the width. This is how thick each one of these are going to be. So let's take a look. So that's going to give me what? 2. 1, 2. 1, 2. 1, 2.
And 1, 2.
There we go. All right. So my area on this one now is going to look like, if it's going to be a left hand, right? Okay, so I'm going to make this out. So area is going to be equal to my width, which is what? 2 times what the height of my first left-handed? 0. Plus. What's my width? 2 times. Okay, because I'm plugging in the 2 value, right? 4. Plus 2 times. Now, what am I plugging in this next time?
4.
What's this going to be? Let's take a look. At 2, it was 4. At 4, it was 16. Okay? So, it's going to be 16 plus 2 times. Now, let's see. There's 16. So, let's see. That's 2 is 4. 4 is 16. 6 is 36. Plus. Okay, and then 8's going to be. 8's going to be what? 64.
I don't understand the thing. Where'd you get the numbers?
I mean, you plug in the coordinates to the function x squared. Like, you have like a point 2 and you plug it in. Or
Is that better?
So why wouldn't you multiply the 64 by 2 if you multiply every
I'm going to. I just showed I expanded this out again. Instead of just plugging it in, because for each one, for the y value, the height of each one, I just plug this in, right? Because I know that this is going to be 0, the x value is 0, this one's 2, 4, 6, 8, and 10, right? And these are all left-hand alignments, aren't they? So if it's all left-hand alignments, that means that it's f of 0, f of 2, f of 4, f of 6, f of 8, right? Yeah. And I'm plugging that all into right here, right? So I can go through and actually add all this crap together now. So that's going to be, so it's going to be 0 plus 8 plus 32 plus, where am I at? Right there. What's that? 72 plus 128.
What?
64 times 2.
You forgot the times two.
There you go. Sorry. Yeah. Oh, I had it here, but I didn't put it here.
Okay.
I know. I'm sorry. I apologize. Sorry, YouTube, for all those people watching. My one viewer from Nova Scotia.
From where?
Nova Scotia.
What is Nova Scotia?
Canada, eh?
Really?
Yeah, they have maple syrup.
You're a famous.
No way,
Maple
hoser.
syrup.
Yeah, you hoser. All right, so add this crap together. Add this crap together.
Start war.
Okay,
Together.
we have 40 plus, crap, what's that, 90,
Come on, teacher.
200.
200.
240.
So I get 240 units squared. So this is going to be my 5 intervals, left-hand alignment, underestimation for the area under this curve. Did I confuse the crap out of anyone?
Nope.
Is this very easy?
Yes,
It's good, yeah.
it is very easy.
It's super easy. So, graph this. When you draw this out, listen, for your problems, if you have to draw it out, draw it out. It makes a lot more sense visually to see what you're working on and where. Draw the rectangles. Look at your width. Okay? All right, so we're going to finish up the rest of this tomorrow. So don't forget, everyone,
Even
like,
the-
subscribe.
The sink. Oh my goodness. Mr. Pasha.
Yeah,
Even the sink.
even the seek.
C.
See?
Yeah.
C's page.
Se puede?
Like we did A and B, what about C?
Oh, yes, we're going to do that.